This is going to be 7.3, and it'll be another relatively quick section, honestly, so we'll just jump right in, get through it as quickly as possible. 7.3, use functions involving e. Okay, and that's a lowercase e, has to be lowercase, okay, because it's a number, okay, much like pi. So just kind of information, e is Euler's number, and we call it the natural base e. And it's a special number just like pi, or I is another one that we've done. So the official definition is the natural base e is irrational. It is defined as follows. As n approaches positive infinity, 1 plus 1 over n raised to the n approaches e, which is approximately 2.718281828. Okay, so this is the number, okay, when we're approximating it, we usually just use these first three, like 2.71, much like with pi, we use 3.14. Some people will say 2.72 because of that rounding with that 8, okay, but typically you just hear 2.71 or 2.718 when people are talking about that number. Alright, so this section has a couple of things in it. We're dealing with simplifying natural base expressions. And then we're dealing with showing if it's exponential growth or decay. Okay, and this will be without graphing. Okay, in the last two sections, or the last video, okay, we did it by graphing, but now we'll just be able to look at it there. So, before we jump into this, I'm going to go ahead and get all the note stuff in, so that way we can just jump into problems. So, natural base functions. Okay, a function of the form y is equal to ae to the rx is called a natural base exponential function. Now this is the important part. If a is greater than 0 and r is greater than 0, okay, so if a is bigger than 0 and r is greater than 0, the function is an exponential growth function. But if a is greater than 0 and r is less than 0, the function is an exponential decay function. Okay, and there's graphs of those things in your book on page 493 if you need to look at a graph of those. Okay, so now let's just jump into some problems. They're really nothing complicated here. So this first stuff is going to be just to simplify the expression. So simplify the expression. So this is basically just going to be following using rules of exponents, rules of just like canceling stuff, like you know, in general. So we'll fly through a few of these problems here. So number 4, e to the negative 2 times e to the 6. Well, we know that according to rules of exponents, when we're multiplying two numbers the same base, and they have different powers, we just add the powers. So this is e to the negative 2 plus 6, which is e to the 4. Six, in parentheses, 2e to the negative 2. Outside of the parentheses, everything is raised to the negative 4. So what do we do here? Well, this negative 4 goes to both things in here, okay, by rules of exponents. So we end up with 2 to the negative 4 times e to the negative 2 times negative 4. Okay, remember, when we do this, we're multiplying these exponents. That's why it's like this. So this negative exponent here brings this 2 to the bottom. So we're going to end up with something over, oops, not e, 2 to the 4th. And here, now I can multiply these. Negative 2 times negative 4 is positive 8, so that stays on top. So e to the 8 over 2 to the 4th. So e to the 8 over 2 to the 4th is, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So then that's our answer for that one. I should be boxing all of my answers here. Let's see. And keep in mind, when we're doing stuff like this with adding exponents, it still requires like terms. So if this had an x on it, okay, here it would be negative 2x plus 6, and that would be how it would stay if there was an x, because we still have to deal with like terms here. So number 10, e to the x times 5e to the x plus 3. And notice this x plus 3 is only on the e. It's not on the 5. It's only on the e. So we can just stick the 5 out front. Now I can add these things up here. So it's going to be e to the x plus 3. Okay, because I'm adding exponents because we're multiplying, meaning that we get 5e to the x plus x is 2x. Can't add the 3 just onto that, so we're just going to say plus 3, and that would be the answer. Okay, so the like terms, so adding, subtracting, like terms still applies. Let's see here. $14, the last one of this type. 14, 6e to the 4x over 8e. Well, this 6 and this 8, okay, I know I can pull a 2 out of both things, so that makes a 3 on top and a 4 on the bottom. So that's going to be 3 over 4. Now, I have an e to the 4x, and I have an e down here by itself. So to move it to the top, I have to subtract the exponent. So this gives me e to the 4x minus 1. Okay, again, just basic rules of exponents here. So now, to officially write it, okay, I would be fine if you left it this way, but the book is going to write it this way. 3e to the 4x minus 1 all over 4. So hopefully that makes sense. Now, this next set of problems, if you don't have your calculator close by, pause video, run and grab your calculator, get it out of your backpack, or I don't know, wherever you have it. Take a minute, grab that. Get mine handy here. Alright, so this next set of problems is to use a calculator to evaluate the expression. Alright, so here, all we're going to be doing is punching stuff in our calculator. So we're just going to do like 2 of these probably, and that will be it. So like 20, we have e to the negative 3 over 4. And we want to know what that is. So come over to your calculator. Trying to get it to where there's not really a glare on it as much as possible. Alright, so on your calculator, okay, obviously turn it on, come all the way down, and you'll see this LN button, okay? And it's really hard to see it because of this glare and just it's so small. But right above the LN is a button that has e to the x, okay? So on your calculator, what you're going to do, okay, I'm going to try to write out the steps here so you guys can see it. Hit second, okay, and then hit the LN button, okay, hit the LN button, which gives you e to the x, and now we just need to replace this x here, so second, LN, gives you e, and then it's going to bring you up a box, okay, and now we just need to type in negative 3 over 4. Okay, so it looks like that up here. Let me see if I can bring this down a little bit and maybe help some with the glare. That might help a little bit. But e to the negative 3 over 4, and that's going to give me approximately, and we're going to say go out to 3 decimal places. So that's approximately 0.472. Okay. Let's see, one more. Let's do 30. 30 is 0.4 e to the 4.1. So now I need to put in the 0.4 first, so I'm going to just do 0.4. It doesn't need the 0. And then sec. And now I can type in 4.1. Hit enter, and in this case I get approximately 24.136, okay? So 3 decimal places there, and that's all you have to do for that. Alright, and then the very last thing we're going to do here, so honestly with those, once you calculate, I'm only going to assign you like 2 of those because as long as you can type in your calculator, you're good to go. So, the very last thing says to tell whether the function is exponential growth or decay. Exponential. I did way too many ENs there. Exponential growth or decay. This right here is why I'm a math teacher, not an English teacher. Alright. So remember back, before I put a problem up, we're looking back at these rules here. So if A is greater than 0 and R is greater than 0, it's growth. A greater than 0, R less than 0, it's decay. So let's take a look at these functions. 32. F of x is equal to 1/3 e to the 4x. Alright, so the way I would like you to look at this, okay, this is A, so we're going to say A is greater than 0. Okay, and then, just so that you have to think about it, this is R. So R is also greater than 0, meaning that it's growth. Okay, you don't have to write exponential, you can just write growth, and I'm fine with that. Let's see, 34. Do 2 more. 34, f of x is equal to 3/5 e to the x. Alright, a is 3/5, so a is greater than 0. R, now, we don't see an R immediately here, but we know that there's an imaginary 1 here, okay, which is R, so R is also greater than 0, so again, we have a growth function. And lastly, 38, is f of x is equal to 4e to the negative 2x. So, a is 4, so a is greater than 0. R, well, R is now negative 2, meaning it's less than 0. So according to our rules, this is decay. Okay, and that's all you need to show for those problems there. Okay, but you have to show this or you will not receive full credit for those problems. Okay, so now, homework for this section. Homework here is going to be (3 through 17) odd. Okay, you want to make sure that we can simplify and everything correctly. And number 17 is just an error problem, finding the error. For the calculator ones, so we're going to say here from 19 through 30, pick 2. Okay, so you get to pick your own 2, pick your favorite. Okay, as long as you can do them on your calculator, I don't care. You have to show me 2 of them though. And then for the growth and decay, (31), 33, and 37. Okay, so it's a few more problems, but they shouldn't take you a super long time, especially to do these ones here. They should be pretty quick. So if you have any questions, remember, let me know. Best to understand this. And I'll get back to you as quickly as possible, either with a video or just a quick little text response, depending on what I feel the question needs. Yeah, have a great day.